Okay, so I had to cut off the last video kind of short, so you missed me going over question number 9. So this is number 9, 1 minus tangent squared theta divided by secant squared theta. And what I was going to do was, because this part is a complex fraction, first thing that I did was break it down. Tangent is sine squared over cosine squared. Secant is 1 over cosine squared. Then what I was explaining was that I'm going to multiply by the reciprocal again. And the reason why I can do this is because dividing fractions is the same thing as multiplying by the reciprocal. So it's not like I changed something. I don't want you to get confused and think that I need to multiply by cosine on the left-hand side as well. I'm really just manipulating that fraction, but I'm not changing anything. So once I do that, you can see that the cosine squares cancel out, and I'm left with just sine squared theta. And 1 minus sine squared theta, that's a Pythagorean identity, and that's equal to cosine squared theta. So that was number 9. And then let's go right on to number 10. Number 10, we have sine squared theta times cosine squared theta times tangent squared theta times cosecant squared theta. So this just looks like a lot of stuff being multiplied together, so let's rewrite it in terms of sine and cosine. This still just stays sine squared theta over 1. Cosine stays the same, cosine theta over 1. And then this is where things are going to start changing. Tangent can be written as sine over cosine. And make sure when things are just tangent and not tangent squared, you just have to be careful about whether or not the function is being squared or not. And then the last one, cosecant, is 1 over sine theta. So now let's go through and cancel some things out. I can see that sine cancels out with sine, cosine cancels with cosine, so this whole term is really just equal to sine squared theta. Okay? I don't think that these are really that hard. I'm sure that you don't think so either. So this is the last one, and it is different this time. So number 11. This time we have cosine theta is equal to negative 5/13, and theta lies in quadrant 2. If the values, or find the values of the remaining 5 trig functions. So we haven't done a question like this in a couple of days, so let's do one of these. So we have to find the remaining 5 trig values. So when we do things like this, I always want you to write out, all students take calculus. Let's just take special note of the fact that we are in the second quadrant, so we lie right there. SOHCAHTOA probably would also help. And then I'm going to write out sine theta, cosine, like all the things that we're going to have to fill in just to make it easier, just to remember what it is that we need and what we're being asked to find. Okay? We have to find all 6, so we need the reciprocal ones as well. Also, while I'm doing that, I would note that because we're in the second quadrant, cosine is negative, tangent's negative, and their reciprocals are going to be negative as well. So sine and cosecant are the 2 that are positive. That one's negative, and so is cotangent. Okay, so now what we're going to do is we're going to use the information that's been given to us to figure out what the missing parts are. So we already know that cosine is 5/13. And what I'm going to do is I'm going to use that information, come down here and make a triangle and fill in the parts that we know, and then figure out what we still need to know. So when you're doing something like this, you can just pick any angle as theta, well, besides the right angle, because obviously we know that's 90 degrees. And if cosine is the adjacent over the hypotenuse, then I know that the adjacent side is a positive 5, not negative. The negative just tells me which quadrant I'm in, and the hypotenuse is 13. So I need to find that missing, or that, I'm sorry, that is supposed to be the adjacent side, and I labeled that incorrectly. So the adjacent side is right here. We need to figure out what the opposite side is. So we're going to use Pythagorean theorem, 5 squared plus x squared is equal to 13 squared. Five squared is 25. I don't have my calculator open, but 13 squared is 169. So x squared is equal to 169, 149, 144. So x is equal to 12. So my opposite side is 12, and now I can use this triangle to fill in all the missing pieces of information. So sine from SOHCAHTOA is opposite over hypotenuse, so 12 over 13. And tangent is opposite over adjacent, so 12 over 5. And then I'm just going to flip all of these over for the reciprocals. And luckily, none of these are radical symbols, because if they were radical, we have to rationalize everything, and that's just not fun at all. Okay, so those are all 6 of your answers for number 11. And those are all the answers for homework number 81. Okay, now we're going to move on to homework number 82. And I know that this probably doesn't seem very much fun to you, but I do want to make sure that you understand all of these before you take the test. So I guess I don't really feel that bad. Homework number 82. This is page 354. 354, probably through 355, numbers 13 through 20. Okay, so you have that page open already, and this time, number 13, it's a very similar question to what we just did, except for this time it tells us that secant theta is 4/3, and sine theta is greater than 0. So we're using other pieces of information to try to figure out which quadrant that we're in, and we have to find the remaining trig functions. So sine, cosine, tangent, and the reciprocals as well. And this just, it kind of adds just a slight twist to things, but that's okay. So the reason why they're giving us that information above about where sine is because it needs us to use our knowledge about what is positive in which quadrant to figure out which quadrant that we're actually in right now. I'm going to make all students take calculus, and let's figure that out. All students take calculus. Now I know that sine is greater than 0, or sine is positive. That means that I'm either in the first quadrant or the second. So I'm not here and I'm not here. Now secant theta is positive. Secant happens to be the inverse of cosine. So secant is going to be positive wherever cosine is positive. So secant's positive in the first quadrant and in the fourth quadrant. It's not positive in the second. So I can get rid of this, and I know that we are within the first quadrant. What's great about that is because we're in the first quadrant, all of our trig functions are all going to be positive, so I don't even have to worry about anything being negative right now. I know that secant is 4/3. Therefore, cosine is 3/4. And then I can use, see, they're trying to trick you. They're giving you secant, and secant is technically, well, cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent, but that's just a little bit too confusing to think about. I mean, it's not that confusing, but if you could figure out this is secant, therefore this must be cosine. All right, now I know I can use that piece of information to figure out what my other sides are. So I'm going to make this my theta again. Cosine is adjacent over hypotenuse, so 3/4. And I was telling you about those Pythagorean triples again. 3, 4, 5 is a Pythagorean triple, but don't get confused, because that 5, that biggest number, has to be the hypotenuse. And in this case, it is not the hypotenuse. So my guess is that there's going to be a radical in here, but let's just figure this out. 3 squared plus x squared is equal to 4 squared. So this is 9 plus x squared is equal to 16. Okay, so x squared is equal to 7, so x is square root of 7. So because we have that means that I now am going to have to rationalize some things, but that's okay. Sine is opposite over hypotenuse, so radical of 7 over 4. And then tangent is opposite over adjacent, so radical 7 over 3. Flip those over, and then I'm going to have to rationalize. So this is 4 radical 7 over 7 after I rationalize everything. And this is 3 radical 7 over 7. And you can do that out if you on your own if you'd like. But that is number 13. Okay, that was a lot of work for one question, but that's okay. Number 13, let me just check how long I have. Okay. Number 14. The expression tangent squared theta divided by sine squared theta is equivalent to what? Well, tangent is sine over cosine, or sine squared over cosine squared. And in the denominator, I can write sine squared just over 1. And now I'm going to have to multiply by the reciprocal. So I'm going to multiply by 1 over sine squared theta. On the top and on the bottom. And I'm really sorry that this is messy, but it's not really getting easier to write with a mouse. That's okay. All this is gone. This and this are gone. So that's actually 1 over cosine squared theta. 1 over cosine squared theta is the same as secant squared theta. That's number 14. And let's move on. Number 15. Okay. If cosecant theta is equal to negative 5/4 and theta is in the third quadrant, then we have to find cosine theta. Okay. So this is similar to what we had to do above, but before we had to figure out what all of the functions are. This time all I really care about is cosine. So let's see. We are in the third quadrant. That means that because I'm in the third quadrant, cosine is going to be a negative value. I just don't know what value it is yet. Now, cosecant is the reciprocal of sine. Now, sine is, from SOHCAHTOA, sine is opposite over hypotenuse. So if cosecant is the reciprocal, then this is the hypotenuse over the opposite side. Okay? So I need to figure out what cosine is, and cosine is adjacent over hypotenuse. So my adjacent is, or my hypotenuse is 5. I need to figure out what that adjacent side is. So let's make my triangle again. I'm going to put my theta right here. My hypotenuse is 5. My opposite side is 4. This is the case where the 3, 4, 5 triangle does work. That is a Pythagorean triple. 3, 4, 5, because 3 squared is 9, plus 4 squared, which is 16. 9 plus 16 gives me 25. Square root of 25 is 5. So I don't even need to do this. The adjacent side is 4, so the cosine is negative 4/5. Make sure that you have that negative there, otherwise you're going to get the question wrong. Okay, that was number 15. Let's go on to 16. Sine squared theta plus cosine squared theta plus tangent squared theta. Hopefully you're getting pretty comfortable with these at this point. I just really want to make sure that you know what you're doing before you take that test. You did very well on the last test. I just really want to keep up this streak that you have going. So when you look at this, sine squared theta plus cosine squared theta, that's just equal to 1. 1 plus tangent squared theta is actually just equal to secant squared theta, which is one of your Pythagorean identities that you should have written down. Okay?